Hey everyone, how's it going? Today I'm going to go through the genetic disorders by chromosome. It's a table from First Aid for step one. Basically, you need to memorize to just kind of recall what disorders are on which chromosomes. For me, it was a pain to just memorize this table. So for me, I need like a little hook for each disease. And then I think that should be pretty helpful. So hopefully it helps some of you. Um, Let's just get right into it. So we'll start with von Hippel-Lindau. Von Hippel-Lindau, 1, 2, 3 letters must be on chromosome 3. Also, if you remember from pathoma or wherever you learned it, von Hippel-Lindau leads to, what's the cancer? Renal cell carcinoma. So you can also remember that renal cell carcinoma is on chromosome 3. You know, kind of goes hand in hand with von Hippel-Lindau. Next, so for the autosomal dominant polycystic kidney diseases, basically you have PKD1, and you have PKD2. Okay, now these are the autosomal dominant polycystic kidney diseases. This chart does not have autosomal recessive. Okay, so the goal for these is to get to the number 16. If you remember 16, you're done. Okay, polycystic kidney disease 2. How do you get to 16? Well, 4 squared equals 16. So PKD2 must be on chromosome 4. PKD1, how do we get to 16? Well, 16 to the first equals 16. So PKD1 must be on chromosome 16. Okay, achondroplasia. All I remember for this is Tyrion Lannister. Tyrion is a dwarf. So I think about a little dwarf, okay? And he has these, little legs, little arms, kind of 4 little limbs. 1, 2, 3, 4. So achondroplasia, chromosome 4. Hopefully that helps. Huntington's disease, all I remember for that is Hunt. Okay? Hunt. 4 letters, 1, 2, 3, 4. Huntington's disease, chromosome 4. Remember, it's on, just remember the first syllable, which is Hunt, okay? Next is, let's see, okay, Cri-du-chat. So if you write out Cri-du-chat, okay, look at this. 2 letters, 3 letters, 4 letters. What comes next? 2, 3, 4, 5. Cri-du-chat is on chromosome 5. Okay, familial adenomatous polyposis. Sorry about that. FAP. Okay, what do you get with this? You get polyps. Okay, so write out the word polyp. How many letters? 1, 2, 3, 4, 5. Polyp. Chromosome 5. FAP is on chromosome 5. Okay, next, hemochromatosis. I don't have a great way for remembering this, but if you're a chemistry nerd and you remember iron, because that's the problem with hemochromatosis, iron has 26 protons. Its atomic number is 26. Obviously, we don't have 26 chromosomes, so just take the number 6, and then you can remember that hemochromatosis is on chromosome 6. Okay. Next is cystic fibrosis. So if you write out cystic fibrosis, okay? Check this out. First letter, first word, 1, 2, 3, 4, 5, 6 letters. Second word, 1, 2, 3, 4, 5, 6, 7, 8 letters. 6 and 8, the average is 7. So cystic fibrosis is on chromosome 7. Williams syndrome, let's see here. I don't have a great way of remembering that. To be honest, what I do is I know that Cri-du-chat and Williams they're on this exact page, which is page 60, by the way, of 2017 First Aid. But I remember that Williams comes right after Cri-du-chat, and I know Cri-du-chat is on 5, so I just remember that Williams is on 7 because I know it's not on 6 because I know hemochromatosis is on 6. I don't have a great way of remembering that. I'm sorry about that. Okay, the next thing is Friedreich ataxia. So the first thing that pops into my head with Friedreich is you should know that the trinucleotide repeat is GAA. And also I remember that Friedreich ataxia affects you pretty young. Okay, so if you think about a baby, babies are young. So what do they say? They say ga ga ga, right? Ga ga ga. 9 letters, chromosome 9. So remember Friedreich ataxia, ga, and then ga ga ga. You got 9. Okay, moving on. Wilms tumor. Wilms tumor, where is it? Kidneys. Okay, think about the kidneys, and then I just kind of think about, here's one kidney, here's another kidney, and what shape does that I think about this. It looks like this. 11. So that helps me remember that Wilms is on chromosome 11. Okay, moving on. I'm gonna do the 2 globin gene defects right now. Okay, so let's see here. Let's start with beta thalassemia. So if you watch Pathoma, when Dr. Sattar talks about each of the thalassemias, he goes through, beta thalassemia looks like this, and you have 2 beta globin genes, right? And so, yeah, you have 2 beta globin genes, 1 on each chromosome 11, and if, depending on how these are affected, determines the phenotype of the disease. But if you think about how he drew it, to me it looks like the number 11, so that helps me remember that beta thalassemia is on chromosome 11. The way he drew alpha thalassemia is like this one. So remember that there is 2 alpha globin genes on each chromosome, so you have a total of 4. And I just kind of remember that the other time I had 4, I squared it, so I got to 16. And I know that alpha thalassemia isn't on chromosome 4, so 4 squared, 16. Alpha thalassemia is on chromosome 16. Hopefully that helps. Moving on from there, men 1. If you just think about men 1, okay, take the number 1 and write it twice, and you're at 11. So men 1 is on chromosome 11. Okay, moving on from there. Okay, Prader-Willi and Angelman, those diseases go hand in hand. The buzzword is imprinting, and I just remember chromosome 15 for that. I don't have a great way of remembering that, and same with Marfan syndrome. I just know that Marfan syndrome is on chromosome 15. That's all I can really say for those. So chromosome 15, I don't have great tips. We talked about polycystic kidney disease 1, and we talked about alpha globin gene. So we got chromosome 16 done. Chromosome 17, neurofibromatosis. I'm not going to write it out, but neurofibromatosis has 17 letters, and that's how I remember it's on chromosome 17. Okay, let's go to the different oncogenes. I'm sorry, I shouldn't say that. Tumor suppressor genes. So the familial syndromes that are handed down with one tumor suppressor gene, and then that's an autosomal dominant phenotype, but you need a second hit to activate the to actually suppress the function of that protein. And so we'll talk about P53, RB, retinoblastoma, and the BRCA genes. Okay, so what I do is I start with the 2 chromosomes, so 13 and 17. Okay, you just have to remember that these fall on 13 and 17. Okay, and for 17, this is my main bad cancer chromosome. 17 is just a crummy chromosome when it comes to cancers. Okay, and the notorious tumor suppressor gene on period is P53. Okay, so that means that TP53, the gene for P53, is on chromosome 17. Okay, the other one, we always have to pair a tumor suppressor gene with a BRCA gene, and the terrible BRCA that we think about that causes female breast cancer is BRCA1. Okay, so BRCA1 pairs with P53. The other tumor suppressor gene is retinoblastoma. Bad, not as bad as P53, and so I pair that with BRCA2 on chromosome 13. Okay, And then the one other thing that we should talk about is Wilson disease. All you have to remember, simple. Wilson disease sucks. It just sucks. You got Kaiser-Fleischer rings in your cornea. You have basal ganglia problems, ataxia. I'm sorry, you don't have ataxia. Stick with basal ganglia problems. Thirdly, you get liver cancer. Okay, so it sucks. It's unfortunate. And 13 is a pretty unlucky number as well. So we'll put Wilson on 13 as well. Just remember, Wilson's disease sucks. Okay? Moving on from there, the trisomies, so Down syndrome 21, we all know that. And then Edwards and Patau, those are easy. I just use the mnemonics in first aid. So Edwards, think election, you have to be 18 to vote. So it's on 18. Patau, I don't actually remember what they did for Patau. Let's see. Patau, puberty, 13. So when you're a teenager. Okay. Moving on from there. So neurofibromatosis type 2. So for this one, NF2. Remember NF1 was 17 because it has 17 letters. NF2, just take the 2, write it again, 22. Kind of like what we did with MEN1. We wrote the 1, it was on 11. Neurofibromatosis type 2 is on chromosome 22. The George syndrome, I just remember 22q11. I don't know why, but this just kind of sticks in my head, and hopefully it does for you too. And if you remember 22q11, you know it's on chromosome 22. And the X stuff is easy. So I think that's it. Hopefully that was helpful, and best of luck on your test.